Hello and welcome to the December webinar from the IEA Clean Coal Centre. My name is Deborah Adams and I'm Communications Manager here. Our monthly webinars are based on our technical reports which are available from our website www.iea-coal.org. Residents of member countries and employees of sponsoring organisations can download our reports at no charge after a one-off registration. Please visit the website for details. Today's webinar is presented by Dr. Leslie Sloss. Her subject is the outlook for environmental equipment under new mercury emission regulations. Her report on the subject is out in draft at the moment and will be published and available on our website early in the new year. If you have any questions during the talk, please use the Ask a Question box at the top of your screen. Add your email address as well so that Leslie can send you a fuller answer if we run out of time. Okay, now I'll hand you over to Leslie.
Thank you, Devo, and welcome everybody. Thank you for tuning in. As Devo said, my report is out in draft at the moment. The actual deadline for comments is today, so if anyone's sitting on some comments, please do email me them as soon as possible and I'll get them incorporated into the final version. This report is an update of several previous reports I've done on mercury, including many on regulations, on emissions control technologies, and the environmental considerations. And as Debo says, if you're a member or if you're registered on the site, you can download these free of charge. It's also been the subject of previous webinars that I've done, and so I'm going to assume a little bit of basic background knowledge as I take you through this rather than working from the beginning. And so I'm hoping that you know the basic behaviour of mercury in a coal-fired power plant, and I'm not going to show any slides of fish. So to move on to what we're going to talk about today, oh, I can't get the slide to move. This is interesting. There we go. There we go, and I've gone 2 slides. Excellent. It's the joys of using somebody else's computer. I do apologise. Okay, so currently the coal sector, as I believe it, is moving into a time where some mercury control will be standard, and I use the word control rather than legislation, because existing control systems for particulates, SOx and NOx, can reduce mercury emissions from between 10 and up to 95%. And so as plants become cleaner and more efficient, some mercury control is going to be inevitable in all cases. And we talk about a move towards CCUS, that's carbon capture, utilization and storage. Then we're obviously talking about high efficiency, low emission plants, that's the HELI technologies. And therefore there's going to be a certain amount, if not an extreme amount, of flue gas polishing and cleaning going on in the future. And so we hope that most new plants will be built efficiently and with some form of emissions control, and this can only reduce mercury emissions in the future. However, determining a control technology for an existing plant is not simple because of the way mercury behaves. If all the mercury produced from coal were in an oxidized form, it would stick to fly ash or it would come out in any water that it met within the plant. But that's not the case. And so which technology is appropriate at each plant to control emissions has to be determined by an expert. And also we have to take into account the fact that not all countries, or very few countries at this stage, actually require mercury control. And so we're talking about what are you aiming for? In America, the US emission reduction target under MATS, that's the mercury and air toxics rule, is really quite challenging. We're talking about 90, in some cases 95% mercury reduction. And of course, that's going to require a bolt-on technology in many plants. Whereas other countries, the control requirement is less. And we'll talk about Minamata at the end of this talk. And there will be countries that will be committing maybe to only a 50% mercury reduction target. And to them, bolt-on technologies may not be what they're looking for in many cases. And so there are different markets emerging in different countries, and this is what this project hopes to look at. Now, the basic options for mercury control have been covered in previous talks and previous reports. The options for mercury control are basically, there are 3. You can either take advantage of the co-benefit effects, that is the pulling down of mercury in a control system that wasn't primarily designed for mercury. Mercury can stick to fly ash, pull down in an ESP or fabric filter. It can certainly come down in a flue gas desulfurization system or anything with a sorbent involved. And if you have an ox control such as an SCR system, that catalyst can oxidize mercury into the sticky form that we want it in and enhance mercury control. So if you can take advantage of what you already have in place, then obviously that's the cheapest way to do it. If that's not enough, or you don't have these systems in place, then you're looking at more mercury-specific options, such as the oxidants, where you throw in a halogen or another oxidizing agent. It turns the non-sticky mercury into the oxidized form, and it's captured in any system you have available. Or, if you don't have a system available, you put in the secondary, the sorbent, and that captures the mercury in a solid form that can be taken away and disposed of. And then the multi-pollutant system, which is a kind of combination of everything above, which hopes to control several pollutants at once rather than just individual one-by-one pollutants. Co-benefit effects can be hugely successful. We've seen countries such as Korea and Japan and some of the plants in Europe at the moment, they haven't put in mercury control specifically, but they have put in ESPs, fabric filters, flue gas desulfurization and SCR, and because of the nature of the coal and the plant, they are achieving in some cases up to 95% mercury control free of charge, which of course is excellent. Not always guaranteed. If you have a more challenging coal, such as a lignite or a PRB, Powder River Basin, then the mercury is very hard to oxidize, and you're going to have to be looking at more specific control technologies, such as oxidants in those cases. And of course, some plants in some regions don't have FGD or FCR systems as standard, and are not getting the co-benefit effects as yet. So to be looking at more specific options, there are oxidants. On the picture on the right there is a lovely system from Nalco. I'm not promoting Nalco necessarily. I just like this picture as it shows how simple these systems can be. Simple retrofit bolting on of a delivery system for an oxidant onto the side of an existing plant in such a position that suits that plant. So this could be spraying an oxidant into the coal intake, into the boiler, and downstream, wherever it suits that particular plant. They're very convenient, and companies such as Nalco will work with you to promote the best option for oxidization distribution within your plant. Also, on the left there, we have data from a Babcock study, I believe, where they had a plant that, although mercury was being captured in the flue gas desulfurization system, it was being re-emitted and back into the flue gas, which is obviously not what they wanted. And a simple treatment with oxygen into the FGD intake meant that the mercury was captured and controlled. So people and companies producing oxidant systems will work closely with you to produce a system that works best for your plant. Other companies, and sometimes the same companies, are producing activated carbons and sorbents. Now, 10, 20 years ago, people that know me knew that I had no faith in activated carbons at all, because at that stage we were talking about throwing in huge quantities of carbon and creating a whole new waste while losing a potential fly ash commercial sales stream coming out of the plant. And so I wasn't that keen on them. However, times have changed. I admit my mistake, and there are now many activated carbons out there which are really quite effective. They've been developed to have bromines and other halogens or other species attached to them, so that they almost perform an oxidization at the same time as they capture the mercury, which is an excellent way to work. And they've been produced so that they are more efficient, and so you need less of them. So in many cases, it's not affecting fly ash sales by increasing the unburnt carbon. Some are even modified to include sorbents that get rid of this problem that many plants are seeing with sulfur trioxide interference. Sulfur trioxide can be produced, some people inject it for increasing the resistivity of their fly ash. Sometimes it's produced from an SCR system because of the oxidization potential there. And so the SO3 can stick to the activated carbon, which stops the mercury sticking. We don't want that, and so there are ways, companies are developing ways of cutting down that effect. And there are materials being produced by some commercial companies which can produce a product that is a waste material of value, such as something which can be used as a fertilizer. And in the report, I've kind of gone through all of these in details and listed for you. I've also gone through and Googled everything that you can't be bothered Googling or don't have time to Google, I have done that for you. We've Googled everything with respect to mercury control. So in the report you will see data on the toxicon process. That's a hybrid particulate pulse jet system, sometimes with sorbent added. The GORE system, which is an advanced filter system. NewStream, which is an ozone oxidization based system. And SkyMine, which is an electrochemical oxidized system. All new technologies, all quite state of the art and being developed. Perhaps one of my favourite, although I shouldn't say that, is the REACT system. This is a regenerable coke-based sorbent system in a fixed tube which recycles. It is a multi-pollutant system. It captures SOx, NOx and mercury simultaneously, and the way it cycles, it produces materials that can be sold. The sulfur can be captured and sold as a byproduct. Theoretically, the mercury is concentrated over time, and at the beginning they assumed that they would have to sort of change the bottom layer of the coke material maybe every 2 to 3 years and take that waste material away. However, it's been running, as far as I'm aware, for 5 years, and they've not had to do that yet. So as yet, there's not been a mercury problem, and it would appear that when they finally do have to take that mercury-laden layer out, it will be quite compact and easy to dispose of rather than large quantities of activated carbon. That is in place at the Isogo plant in Japan. If you ever have a chance to go and visit any power plant in the world, that is my very favourite. It's so clean that they give you white gloves to wear as you go in and tour the building, and you come out with similarly white gloves. The particulate and SOx and NOx emissions coming out of the stack in Isogo are cleaner than the ambient air. It's almost like an afterburner. It's a beautiful plant, state of the art, and part of the solution for their pollution problem was this REACT system. So as I say, the report goes through all the different technologies that are out there, and I've listed them in a table here, but in the report itself goes into much greater detail of where these systems are in place, how they work. In some cases, there are photographs and diagrams of what they do and how they work. The claimed removal date I've listed there. Sometimes, obviously, I've taken that from commercial brochures, and so obviously they're all going to claim over 95%. It will depend on a case-by-case basis, but if these are commercial manufacturers, they will do their very, very best to get you that reduction, even if they have to tweak the system and how it works. I've also listed the status, whether it's commercial, pilot scale, and where, if possible, which plants are actually demonstrating these technologies in practice right now. So there's a lot of interesting information in the report if you want to go through it. Now, to get on to the good stuff. We know the technologies, we know how they work. What we want to know is where these are going to sell, who's going to buy them, basically. Now, obviously, nobody's going to buy mercury equipment unless they have to, because it's not cheap. And so people are buying it where they have to buy it, and that is where the legislation is. At the moment, that is Canada, the Canada-wide standard, and more importantly, perhaps, the USA, the Mercury and Air Toxic Standard, and the MATS. It's a huge market over there. So I'll talk a little bit about that. I'll then go on to the EU and reiterate why, as yet, there is no specific market for mercury control, but that may change on a case-by-case basis in future. We'll also look at the emerging Chinese market, which could be very interesting, and even potentially an impending Indian market. Okay, so if you look at the USA, the limits are extremely challenging. You're talking about 90 to 95% mercury control at many of these plants. And that is because the way the legislation was set was that the information collection request showed the emissions from all the plants in the USA, and the EPA said, okay, everybody has to get their performance up to the 12% cleanest performing plants in the US. And so everybody not in that 12% has to pull their socks up in some way. For some of the older plants that were obviously at the end of their normal running life, this is just simply too expensive for them to bolt on new technologies at this stage. And so some are closing down or switching to biomass or gas. We are seeing co-benefit effects working at some plants. So at some plants, the existing FGD and particulate control technologies are good enough, but there is a strong mercury market emerging. However, interestingly enough, if anyone was watching the newspapers and the news recently, the MATS rule has been taken to court once again, which is a bit exciting. The US EPA has had a huge challenge with the Mercury legislation. The Clean Air Mercury rule, CAMRA, was thrown out several years ago, and MATS was brought in with a broader scope so that it covered multi-pollutants, particulate precursors, and so on. And it seemed to have reached full enactment, but apparently a group of utilities and industry have raised a DC Circuit appeal and have won. And theoretically, this could mean a rewriting of the rule, or even the scrapping of the rule and start all over again, although this is probably unlikely. But the US EPA is certainly taking this very seriously. Apparently, much of it relies on something known as the Chevron doctrine, which I hadn't heard of before, but it relates to the different interpretation of the wording of a rule. And although the US EPA should have final say on how the rule that they have written is meant to be interpreted, obviously there is a lot of argument going on. Most of it is based on the cost of compliance, because some plants are arguing that the cost is simply excessive. And so this is a hugely contentious subject for many utilities, many of which have money to spend on battering this rule as much as they can. And so it'll be interesting to see how it turns out. However, in the meantime, many plants have already initiated the installation or even completed the installation of mercury control technologies, and many are already so far down the route that to stop installation would be madness at this stage. And so we're continuing to see installation at many of the plants. This is data I have taken from the Institute of Clean Air Studies, IEACCC, Institute of Clean Air Companies. And they have a database of who's buying and installing what. And we can see that many units in Canada and the USA have already installed activated carbon, and many more are planned. That limit on the right there are about 55 plants that are still popping ACI units on as we speak. Looking at the different coal types, then the majority of plants are subbituminous, and therefore the majority of installations are on subbituminous plants, with many more planned. I mentioned briefly earlier that some coals are more challenging than others, and this is specifically for lignite and Powder River Basin coals, which tend not to produce the mercury in the oxidized form. And so these have different technologies that are emerging for these plants specifically, and these tend to be more oxidant-based, especially bromine-based, such as the KNX system there, shown in green. It's very good at oxidizing mercury and is being used at several subbituminous plants. We also have the cyclene system, which is a liquid oxidant, which is very popular for Powder River Basin coals, and M45, which is also a liquid oxidant and is often used in CFBC, circulating fluidized bed boilers. And so although many of the standard plants are installing ACI, we're seeing a sort of niche market for the more challenging cores appearing, which is more additive based. There are also multi-pollutant systems. Some of these are really quite exciting new technologies based on, for example, the airborne is an oxidant and dry sorbent combination, and it's being tested at the Ghent plant in Kentucky on a slipstream, with 2 tests also underway, interestingly, in China. The new stream is a dual alkali and FGD combo process being tested at the Drake plant in Colorado, and is going full scale on 2 units, I believe, at the end of this year. SkyMine is a sodium hydroxide based system which is being used at Luminant's Big Brown plant, and the React system that I talked about at Isogo in Japan is also being installed at Western plant in Wisconsin by December 2016. And so we're seeing a few of these sort of state-of-the-art funky systems appearing, mainly in America, but a few being tested in the new Chinese market. Now, if I had £1 for every time somebody asked me why the European Union doesn't have mercury control, I'd be worth at least 50 quid. It tends to be the most popular question ever asked. The EU does not have mercury-specific legislation at this stage. It does have, as of next year, an annual monitoring requirement for mercury, which shows that it's got mercury on its radar. What it does have is a plant permitting scheme, so it's on a plant-by-plant basis. So each plant in the EU has to take into account the legislation coming down from the Commission, but also any additional national legislation and any regional requirements. And so each plant will have different targets to meet. And we're actually seeing 3 plants, I think, 2 in the Netherlands, 1 in Germany, which are looking at mercury-specific limits. These are new plants, which are quite challenging and could require polishing technologies. But there's nothing published in the media about that, so as soon as I know, I will write a blog on it. But there's certainly something out there, and plants are starting to do something in Europe. However, it's not across the board because we have this IED, the Industrial Emissions Directive. And just to make a broad sweeping statement, the IED means that if you don't have flue gas desulfurization and probably SCR by 2023, then you're not going to be able to operate your plant. That's how strict the limits are. And so we're going to see significant co-benefit effects guaranteed across Europe. And that is why the EU is not doing anything as yet. However, the annual monitoring requirement suggests that they may step in and set a limit so that some plants might have to do something in future. Also, they're preparing what we call BAT reference documents, BREFs. These are best available technology, MACT as you call it in the USA. And that is a guidance on how to reduce mercury emissions should legislation come into play. Now, it's quite an extensive document. It's huge. If you've seen it, if you've read the POG document that we produced for UNEP, the Process Optimization Guidance document, it's free as a download from the UNEP site or from the IEA Clean Coal Centre site. It's basically just a catalogue of all the different options you can use to control mercury. And it doesn't tell you which is best for your plant. You're supposed to work that out yourself. And the BAT is even less guidance, if I can say that without being insulting. They haven't said what you have to do. They've just said where it's generally applicable, which is obviously to pretty much all plants. The only thing that's not generally applicable there really is switching fuel choice, when of course that's going to be dependent on which fuel is available to you. So although that's out there, it's not. It's a catalogue of what you might want to do should your plant require to do something. It's not prescriptive in any way, and the BAT reference document never will be prescriptive in that way. And so another reason why the EU has never done anything about mercury is just look at the emission reduction we're seeing between pretty much now and 2050. If you follow that, there's a sort of creamy-coloured baseline running along the top there that's hard to see. But you can see that huge chunk being taken out of the mercury emissions for the EU because of our climate policy. That is the general move away from fossil fuels to nuclear, renewables, biomass and so on. So huge chunks come down there. And if you were sitting there as a legislative person, you look at the bottom one as well, and you see that the coal sector emissions have just practically disappeared. If you're going to regulate something in the EU, then your focus is clearly taken to waste and dental sources and other processes. And this is why the coal sector is slipping, not under the radar, but is certainly not making any warning lights flash in the EU at the moment. And over there on the right, we have a summary of accession countries and CIS states showing that although their emissions may come down a little bit later, we also expect their emissions to come down in the conceivable future. This I threw up because it's really quite interesting, showing the mercury emissions from the EU countries in the last decade. I think it's 2003 to 2013. And it's on a percentage basis, so some of these emissions actually started out really low and have got really, really low. But we can see that kind of everybody's reduced their emissions from all sources. And I know that I'm talking and nobody's listening because you're all looking at Liechtenstein. What is Liechtenstein done? Well, Liechtenstein opened a biomass plant. That's what that little blip is. Liechtenstein clearly had pretty much no emissions of mercury whatsoever. Built a biomass plant, and the tiny amount of mercury in that biomass material, which has come from recent emissions, so emissions to soil and water being brought into the biomass material itself, being re-emitted. So not really concerned. So let's not get too worried about Liechtenstein. So the market in the EU is really not there because our co-benefits are working really well and we expect them to continue to work really, really well. However, we have the BAT reference documents there ready, a catalogue ready, should we need to do something. As yet, it's not compulsory. However, it may appear on a plant-by-plant basis because we know there are countries within Europe that like to be that little bit cleaner than everybody else. And also new plants, those installing or intending to install carbon capture systems, will obviously be looking at tighter emission control and more state-of-the-art mercury control technologies. Moving on to China. Some of you will be aware, but some of you may not, of just how clean China has become in the last year. It's phenomenal. The new emission limits for China for new coal-fired power plants are actually as tight, if not tighter, than the emission limits seen in the USA and the EU. And this means that they are controlling their mercury emissions as a co-benefit effect. That little graph down on the right there shows you that although emissions should have gone up between 2007 or 2005, so I've not got the graph on, till 2008, the emissions actually came down, and that's as co-benefit result. The actual mercury emission limit for mercury for China is only 30 micrograms per cubic metre, which is not really challenging, but the fact that they have a standard will imply that they're monitoring it and that they may well control it in the future. Also, if you look at the installation rate of flue gas desulfurization and SCR technologies in China, it is phenomenal. It is off the radar. They're popping them up all over the place, to the extent now that China has the cleanest and most efficient plants in the world, putting the rest of us to shame to some extent. So bear that in mind. Mercury emissions in some of the cities, the mega cities that have been targeted for emissions control are already sort of peaking and starting to come down. For example, in Beijing there, you can see mercury emissions under control. So although coal use is increasing, we're seeing emissions levelling off because of the co-benefit effects of the incredible installation rate of control technologies. And also, of course, Obama and the Chinese announced the cap on coal use, with China expecting to cap its emissions by 2030. Obviously, at the Clean Coal Centre, we see how difficult this will be for them because of the population and the growth rate and electrification in the country. So there's very interesting times ahead in China, but they've created a challenge, and hopefully they will step up and meet it. So as for the Chinese market, co-benefit effects will be significant. They're going to see 70, 80, 90% hopefully mercury control at the plants with the FGD and SCR in place. They don't have much experience with bolt-on technologies such as oxidants or sorbents, but you have to remember these are the Chinese, and they're extremely good at learning how things are done and doing it faster and more cheaply. And I say that with the utmost respect. 70% of the global particulate control market is based in China, so there's no reason why they can't do the same with new technologies for mercury. Since the build rate is so fast, many of their plants could consider going straight into multi-pollutant control systems rather than separate FGD, SCR and different technologies. It might be more cost effective to look at react-based systems. And it's interesting to note that the Beijing Research Institute of Coal Chemistry is already developing its own sorbent, which is very similar to the react system that we see at Tisogo. We also know that the E-beam, Lextran and other systems are currently being tested or have been tested in China. So I'll be very curious to see whether they then perhaps copy these technologies or buy these technologies. Very interested to see how they will move on from that. India. Everybody assumes nothing is happening in India, but actually something popped up in the Hindustan Times only last week, which suggests that the Indians are taking the Minamata Convention quite seriously and are actually suggesting setting a mercury emission standard along with emission standards for SOx and NOx. This is going to be a huge challenge for them because of the capacity of the plants over there and the fact that many of their plants don't even have FGD and DNOx in place at this stage. So they have admitted that it's not going to translate into absolute mercury emission cuts, but will reduce the overall emission rate per generating unit of electricity. So it's a start. And they've also admitted that it's going to take them a long time to actually meet the new standards, and especially when you consider that India plants are old, a lot of them, and they're running at full capacity because demand is greater than supply, and so taking older plants offline for retrofitting is not an easy option for them. But at least they've stepped up and said that they're going to start doing something, so that's really quite exciting. And as a result, we've decided that we will have our mercury emissions from coal workshop in Chennai, India next November. So I'm hoping that you will come and join me. will actually be in India. We'll go to an Indian coal-fired power plants, and we'll talk to the people over there, hopefully involved in this legislation. That's our hotel on the top right there. I've been promised that it will be finished by then, because at the moment it's a bit of a construction site. So exciting times. So, quick conclusion. The market is going to follow the legislation. Nobody's going to install something unless they have to. So, the moment USA and Canada are installing furiously, but there may be something emerging in China, and we're seeing them looking at the options available to them. However, they may well create their own marketplace within China once they know how to do it. The EU market is going to be on a case-by-case basis, and it's going to be based on polishing techniques. They're more likely to purchase off the shelf, so I suspect that if the EU does need something, they will look to the US and to the expertise over there. The Indian market could be opening, but it's going to be taking a while to develop. However, having said that, the options relevant in India could be huge, everything from coal cleaning and coal blending through to the polishing and bolt-on technologies. And also with the rate of coal build, they could also be looking at putting multi-pollutant control technologies straight in there. Other Southeast Asia countries, we did a report recently on mercury emissions from these countries. They are, some of these countries have co-benefit effects. Thailand and Vietnam have FGD on some of their plants, and so we'll see some co-benefit effects. But as they sign up to the Minamata Convention, there could be a large market opening up there. They will follow China to some extent, and so our market is emerging in these regions. Finally, a quick update on the Minamata Convention. We're working on the BREF guidance document. It is very similar to the POG that you can download, very similar to the BREF reference materials in that it's just a catalogue of all the options. There are no commitments made under Minamata as yet, and so countries may choose for emission limit values, reduction targets, or BREF. It remains to be seen. However, bear in mind that the Global Environment Facility is announced funding for Minamata, and therefore those countries that might have been tentative about signing up will be more keen because they know the money is available there for compliance. And so a market will develop basically on a case-by-case basis depending on how these countries comply. If you want to know what's happening, then log on to the Minamata Convention website. Just Google Minamata Convention, click, and you will come up with the draft and the text and so on. But you'll also get the snap of who's signed up. At the moment, there are only 9 parties to the convention, 128 people, signatories, therefore interested. It needs 50 parties to be ratified, but if the EU comes in, then that's obviously 27, 28 countries that will sign up almost immediately and altogether. And so it could happen, we believe, within the next 18 months. As I said, Minamata may push the market a little bit, but it will be determined on a country-by-country basis. Hopefully, it will lead to a coordinated approach as people follow the examples set elsewhere. And it will lead to new markets, especially in Asia, but also potentially in Russia, South America, and Africa. It will be determined by the strength of the commitment of each country in turn. And the GEF hopefully will give it that little bit of an extra boost to get it working in practice. Thank you very much for your time. I'm going to answer a couple of questions now. Please remember to come to India if you're interested at all, and also email me if you're too shy to ask a question just now. Thank you.
Okay, thanks Leslie for a very interesting presentation. We'll just see what questions have come in. Okay, we've just got one. Leslie, can you give me an idea about how much mercury control costs?
Thanks, Devo. Yeah, the control cost is always a question we get asked, and we have tried in previous reports to give a guidance on in terms of high, low, medium costs, because it varies so much on a plant-by-plant basis. In some places, we're going to see it costing virtually nothing because of the co-benefit effects. In other cases, the expense can be quite extreme. I think the NERC quoted that on average it was adding the cost of a cup of coffee per week to the electricity cost in the USA as a result of MATS. So it's not huge, but it might be slightly noticeable if you go for the extreme control stage. Thank you.
Okay, thank you very much. Well, we just wait to see if any more questions come in. Can I tell you that Leslie's PowerPoint will be available to download from the webinar page of our website tomorrow. And the next webinar from the IEA Clean Coal Centre will be presented by Paul Barua on Wednesday, the 21st of January. His topic is an assessment of the global biomass resource for co-firing. Okay, and we have another question for you, Leslie. There is a talk about moving the mercury from air to water, FGD streams. Can you talk about that a little?
Hi, thank you. I'm pretty sure that was the subject of previous reports. Obviously, if the mercury goes through an FGD system, then it's either going to come out in the wastewater stream or most likely in the sorbent material itself. People have raised concern about the mercury in gypsum, but as far as I'm aware, the EPA have regulated or at least determined that that's not really an issue. I know that the Israelis are particularly concerned about where mercury ends up in building materials. If you're using FGD materials for wallboard or fly ash for cement, then that shouldn't be seen as a permanent resource for mercury because, of course, buildings fall down or catch fire. But for the most part, it's quite a stable place for it to be, and it's certainly not regarded as a problem. But there are reports that we've produced on that, so if you want to go on the website, I'm sure there's more information available to you there.
Okay, we're going to wrap that up now. Thank you very much, Leslie. Thank you for listening. Oh, hang on, one more question. Very quick answer from you, please, Leslie. So we're running out of time. Okay, the question is, we're planning a new coal-fired power plant, and we will use SCR and ESP and seawater FGD. Does this configuration help to reduce mercury emissions, and is there any harm for the seawater?
Thank you. Mercury is actually something you would find in seawater anyway, but that's not to say that increasing the mercury in seawater isn't a good thing. I know there's a plant in, I think, Ireland, which has an issue with the amount of mercury in its seawater FGD, and they are looking at how to reduce the concentration of the output into the area. Whether they dilute it or spread it further or control it, I don't know. I would be happy to discuss this in more detail with you by email.
Okay, thank you very much, Leslie. It's been a really interesting presentation. If you've got any more questions for Leslie, please email her at the address on the slide there. Tune in for the next webinar on the 21st of January. Thank you. Goodbye.